And we are live. Welcome, everyone. Let's continue the Tech Excellence Conference. We are going to start with the USA sessions. And the first one is TDD, Theme and Variations by Kent Beck. Well, I'm wondering if I need to, or Kent Beck needs introductions, but let's do a brief one. Kent is a chief scientist at Mechanical Orchard. He's the rediscoverer of test-driven development and an author of 9 books of programming, including TDD led by examples, which started a whole movement among software crafters to build better software. And I would say the rest is history. And I think we can all agree that Kent is one of the greatest of all time. So we are super happy to have you here, Kent. Welcome. And before I hand over the microphone, I would like to let the audience know that if you have any questions during Kent's talk, then don't hesitate to place your question in the YouTube chat section. And then we're going to have a Q&A session where Kent will answer some of those questions. So Kent, welcome. Happy to have you. And the microphone is yours. And good luck for this.
Thank you, Daniel, for that warm introduction. Thank you all for attending. It's great to not see you here, but I'm glad that you are here. I really wanted to thank everybody behind the Tech Excellence Conference for setting up this opportunity for me to talk. Putting together this talk has really given me a chance to reflect on various points in my career, and so here I am, and here you are. The story of TDD starts when I was about 10 years old. So I was born and raised in Silicon Valley. Before it was Silicon Valley, my dad was an engineer, and he would bring home programming books, various kinds. I still know some details of the Burroughs 6700 instruction set architecture for some reason. He'd bring these books home, and I was a weird kid. So I would just pore over these technical books, even though I didn't really understand anything. I hadn't written a line of code at that point, but I was just fascinated by the mechanism. And one of the stories, and I sure wish I could track this down, but one of the stories was about how you programmed tape-to-tape systems. So back in the day, you'd load a program, you'd load input tapes, you'd run the program, it would read the tapes, and it would write an output tape. And then you would take that tape and you would feed it into the next program, the next program, the next program. Today, we'd call these pure functions. But back then, that was just the only way you could program. And this book said, here's how you program. You take an input tape, an actual input tape, and before you start programming, you manually type in the output tape that you expect to get. And then you have a little harness that compares the actual output tape to this reference output tape that you entered by hand. Okay, so that was like, I was 10 years old, long time ago. So that's the very, very beginning of the roots, and that story will come around again in just a second. So what I've done is prepare a timeline of events in TDD as I experience them. Now, one of the weird factoids is that the period from Queen Cleopatra to today, so that seems like, you know, this unimaginable span of time, that same span of time before Cleopatra was when the Great Pyramids were built. So Cleopatra's halfway in between the Great Pyramids and today, which, I mean, it seems like, how could that possibly be that far in the past? Well, this history, while not as long, also divides up in half. From my first experiments with automated testing to when this history concludes is half the distance. There's that many years again after the period I'll be covering where TDD continued to develop. And I was less involved in it at that point. So it doesn't show up so much. But I wanted to give you a sense of here's how this whole idea developed. So back in the day, when we were developing in Smalltalk, Ward Cunningham and I would develop in what we called a workspace. A workspace had local variables, but more importantly, it had chunks of text that persisted and that you could execute. So this is kind of pseudo Smalltalk, just to give you a little flavor of ancient Latin. We'd have a little expression. The object A is something or other. The object B is something. We send A the message with the parameter B, and we get back 17. So we print this out. We think we had some code working. We'd type in this example, and we'd say 17. Is that what we expect to see? No. Okay. What's going wrong? And we go debug, 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 and we keep going until we got the value that we expected to see. And then we think, okay, well, we're not done. We have some other variant where B is something different. And now the answer should be 36. And we would keep programming. And often these workspaces would grow and grow and grow with these example snippets of code and the values that they produced. So that's like 1984-ish is when I came out of college and started programming in Smalltalk. In 87, when I left Tektronix Labs, just before I left, so Smalltalk had been growing and growing and growing. Smalltalk was intended as a personal computing environment. So this is my computing environment, and I can change it however I want to. And there was kind of a West Coast smoking weed in the hot tub kind of vibe to it, where if there was something wrong with our code, we would just know it in our heart of hearts. You know, we were that in tune. And as soon as multiple people started working on the code, that sense of personal ownership started to vanish. And I started thinking, well, we need to have some tests that go along with the code. And this was the point at which I made a significant decision, which was to write the tests in the target language. At that point, there were testing tools, and the testing tools would all have their own scripting language. And so you'd shift between this scripting testing language and the language of the code that was under test. And I thought, I want to unify those two. It wasn't obvious that that was going to work. It was kind of a stretch at that point. But I had a little framework where if you had code attached to a class with methods named test, you could gather those up and you'd run them all. And if they blew up, then you knew that something was wrong. But it was the first time that I, as a programmer, started to take responsibility for double checking my own results and in a persistent kind of way. So that's 1987. By 94, I was an independent consultant. I was talking to teams about how to develop. This is when the roots of extreme programming or the seeds of extreme programming were planted. And I remember I was heading to Chicago to tell a team how they should develop this project. And I knew that I was going to tell them that they should write tests, but I didn't have any way for them to write tests. So the night before I was going to leave, I sat down with my computer and I actually looked at those workspaces that I just showed you. And I said, well, what would be the objectification of that workspace? So if each snippet of code was a test, it's an instance of some class, test case. Sometimes that setup code repeats. So those should be fields of the class that'll get initialized in a setup method. And then there's a test method, which actually takes the values, executes the code that we're trying to test, and then automatically asserts that the 17 is 17 and the 36 is 36. And then we can use composition to put a whole bunch of those together. So that was the origins of this XUnit framework, was me taking that workspace style and objectifying it in this kind of way. So was just a little framework. There's like 3 classes and 12 methods. I thought it was no big deal, except that my client was using it to write hundreds of tests. I remember I gave it to Hal Hildebrand, who was one of the smartest programmers I knew, who was working on an object database and was having trouble with it. And he came back a month later and said, "This is magic." I wrote those kind of SUnit tests for my lowest level of objects, and all of my macro problems went away. The whole thing just worked. So I thought, all right, maybe we're on to something here. And it was about a year later of me writing a lot of tests that I remembered that book that I told you about in the introduction, where the first thing you do is you type in the output tape and then you write the program. So always before then, you'd write some code and then you'd write some tests, and then you write some code and you write some tests. And I thought, well, if I just naively apply this model of writing the output tape first, I would write the test and then I would write the code. And I laughed out loud because it's such a stupid idea. And when stupid ideas are cheap, always try them. Because if they're not stupid, they're really valuable, because nobody else is thinking of it. And you have no competition because nobody else is dumb enough to try that idea. So I had that. Let me take this model and apply it to tests. I'm going to write the test before I write the code. And I just tried it for stack. Stack, new stack is empty. Push 1, pop it. You get the same thing. Push 2, pop them. You get them in the right order. And I was absolutely astonished at how much calmer I was as a programmer. At this point, I had 10 years of professional and 20 years total of programming experience. And I was just full of anxiety because, like, I know of a lot of things that could go wrong. And the more experience I got, the more things I knew that could go wrong. So when I used TDD, I was just calm. Did I break anything? I pushed a button. Nope. What do I need to do next? Oh, I'm overwhelmed. No. I know exactly what I need to do next in this new kind of workflow. So that's where TDD came from, was that moment. And then I was really excited. So I started telling other people about it. The technique went through a couple of name changes. I settled on test-driven development, and people were really starting to use it all over the place, applying it in lots of different places. So in 97, I had moved to Zurich with my family, was living there for a couple of years. My friend Eric Gamma, the design patterns guy, and I were getting to know each other even better. We'd met at conferences and hung out and talked about stuff. But now we were flying to the UPSLA conference from Zurich. We flew through Vienna, which is a weird connection, but there you go, to Atlanta. And what are 2 geeks going to do on a long flight? So I said, let me show you this framework, this testing framework, and test-driven development, which he hadn't done at that time. And you show me Java, which is brand new, shiny programming language. We'll just swap. And let's, just because we're super geeks, let's apply TDD to developing the Java version of this testing framework and test itself. Let's bootstrap this thing. And we're just not going to write a line of code unless we have a broken test first. So about 3 hours into the flight, the batteries died. This is back in the old days, and no power in the seats. Can you believe it, kids? So we were done for the flight, but it was pretty cool. Like, it was easy to add new tests. All the basic functionality was there. Test results were reported in easily readable ways. We get to Atlanta. We hand a diskette with this thing on it to Martin Fowler, because diskettes were the only way you could distribute software at that time. So we hand this diskette to Fowler. And the next day we had people literally tugging on our clothes. Can I get a copy of that? Can I get a copy of that? Can I get a copy of that? And, you know, we'd both written 100 programs at that point. No program we'd written had ever had that kind of a response. So that was a big wake-up call. Like, all right, people really want this thing. We managed to get it up on SourceForge, which was the thing back then. Somebody wrote a user interface for it. It started getting integrated into IDEs and so on and so forth. Then a million clones were launched from that. But that's where JUnit came in a couple of years after TDD was, and I say rediscovered, I don't say invented, I rediscovered, because when I talk to old programmers, people who were programming in the 50s and the 60s, they say, well, how else are you going to program? Of course, you have to type in your expectations before you write the program. How else are you going to know if you're done? This was common practice in one form or another for software development in the early 60s. And then we just kind of lost it. So that's why I say rediscoverer of. Now, that was about when Extreme Programming, XP Explained, was published in 99. So that blew up. It was a big distraction. TDD was an important part of Extreme Programming, because that sort of very connected development doesn't work unless you have very low defect density. So I knew that I wanted to write a book about TDD. Other people were threatening to write books. I thought, what if somebody else publishes it first? I published XP Explain and then the planning book with Fowler. And then I thought, I've got to get this book out there. And so I started writing test-driven development by example, which is a deliberate geeky pun, because test-driven development is development by example. But whatever, if you're not laughing uproariously, I certainly forgive you at this point. And importantly, the cover picture was Chartres Cathedral, which is not the same. They were built at slightly different times under slightly different conditions, with different local decisions that had different macro effects. And yet there's a conceptual unity to this cathedral that's just awe-inspiring. I defy you to walk into Chartres Cathedral and not just stop in your tracks. It's every detail contributes to the details at the next level up in scale, from the entire thing down to the tiniest little swirls in the stone carving. And it's just unbelievable. So that's why that's the symbol for TDD for me. You're making these local decisions with great confidence, and the result is glory at the macro scale. So I published TDD by example, and it was, I think, the first book. A number of other books have come out since then. It made quite a splash at the time, and it remains the best-selling of my books. This is the one that I see the biggest numbers from, and it's 22 years old. So hooray for recurring revenue streams. that it also gave me an opportunity to, and this is what I love about writing books, is the chance you have to really sharpen your understanding of a topic. The last significant event I'm going to talk about is Goose. Steve and Nat are good friends. We come in a lot of ways from the same sort of school of software development, very incremental style. Their use of mocks is very different than the use of mocks I see out in the world, and I'll talk a little bit more about that in a coming slide. But that kind of sealed the, I'm not going to say prehistory, but the appearance of Goose was sort of the end of the classical, there we go, classical period of TDD. Since then, things have changed a lot. I wouldn't claim to know all the details of all the variants. But that's what I know about for the history of test-driven development. And remember, if you have questions, feel free to drop them in the chat, and we'll talk about it. But that's the first 15-ish years. Is that right? 15, 25 years of TDD. And then since then, things have taken off. There's a TDD backlash, yada, yada, yada. Anyway, we'll talk about that some more. Okay. So earlier this year, I published something called Canon TDD, which is, I see a lot of critiques of TDD which are not about TDD. Critically, I'm not saying this is how you should do TDD. There's once you master the basics, there's a million variations, and every context is going to create its own variation, and it should create its own variation, like those two spires in the cathedral. But there's some things that are definitely not TDD. So when I see somebody saying, well, I hate having to write all the tests up front before I write any code, I think, thank you for playing. That's not TDD. So my purpose in publishing Canon TDD is not to tell you how to do it. It's to say there is this thing. Your variations from it are your variations. If you want to critique something that's very different from this, then I'm just not going to take your critique very seriously. So, and I think this is a TDD saturated audience, I was told. So very simply, make a list of the scenarios you know about in which the code should behave. Turn one of those into a concrete test. It will fail or should fail. Or maybe it should pass, and it does pass. That's fine too. But more often than not, it fails. Make that one and all the other previous tests pass. Refactor if desired. Now, sometimes this feels like you do it after you make the test pass, and sometimes it feels like you're doing it before you write the next test. That's fine. You can't tell the difference from the outside. And when the list of scenarios is empty, then the code's done. That's that moment of one of the moments where the anxiety just lifts for me. Like I list everything, all the scenarios. As I'm programming, I add things to that list. When I've crossed everything off, I'm done. And if I can't think of any other circumstances in which the code will fail, I'm just flat out finished. And if I ever want to find out if I'm still finished or if I've broken something, I just push the button. So anyway, that's Canon TDD. If you want to critique something different from this, feel free, but don't call it TDD. Something else I wanted to address is this is a statement I hear over and over, oftentimes from TDD advocates. TDD is not a testing technique. TDD is not a design technique. TDD is not a programming technique. Here's the question I'd like you to ask yourselves. when you want to make this statement. To whom are you saying it and why? What's the purpose? Now, I think there are testers who will say, well, this TDD stuff, that's not really a testing technique. There's designers who see, well, TDD is not a design technique. They're correct. It is not a design technique. TDD is not a programming technique. Yes, it's a programming workflow. And yet, come on, sure it is. If you get tests out of TDD, it's a testing technique. It may be different than other testing techniques, but to say it's not a testing technique is a different testing technique. You might get a different design if you use a TDD workflow than you would without it, but that's a result of getting early feedback on certain kind of design decisions. So it's not a design technique, but it also, sure it is. And it's a programming technique too. So that, now if you still want to say, oh, it's not a design technique, that's fine, go ahead. I mean, TDD doesn't make the design decisions for you. That's what you can use TDD and still have terrible design. Sure. Your design is the composition of all your design techniques. And if your design technique are decisions, if your design decisions are poor, you're going to end up with a poor design. The thing about TDD is you're not going to be insulated from the quality of your decisions. You're rubbing up against them seconds later. So you get feedback. If you choose not to adapt to that feedback, that's fine. But this is something I kind of wish people wouldn't say. I don't say it that way. I would say TDD is a different testing technique. TDD is a different design technique. TDD is a different programming technique. It offers a new context in which you can make testing decisions, design decisions, and programming decisions. Okay. Various people from day one have objected to the name test-driven development. To which I say, you tell me a better name, we'll go with it. In particular, though, this word test seems to really set some people off. Except that they're tests. They're actually tests. There's a fixture, there's a stimulus, and there's an expected response. It is a test. Now, maybe that's me being pedantic to say, well, there's tests, so we'll call them tests. But what else are you going to call them? Examples? They are examples. We are demonstrating, I don't want to say correctness. We want to demonstrate that our expectations match the results of the program by induction. So I'm not going to exhaustively test every possible set of inputs against the expected outputs. I'm going to say, well, there's this one and this one and this one. And from that, by induction, I can say it will work for a wide range of inputs. But the way we do that is with tests. So now there's one of the things we fought against in the early days of JUnit. One of the seminal papers is called "Programmers Love Writing Tests." Eric and I wrote that as a that was clickbait before there's clickbait. Deliberately provocative title because there was a strong social stigma attached to testing. The A students got to be programmers and the B and C students got to be testers. And you didn't want to be a tester if you could be a programmer. This is back in the 80s. So I sometimes wonder if that's part of the source of the reluctance to use the T word to talk about this programming workflow. But I don't know. It doesn't bother me. If it really bothers you, think about why it bothers you and come up with a better name for it. And I'm happy to adopt something better, but I'm not going to adopt something worse just because the T word bothers some people. Another question that comes up frequently in TDD is it a top-down technique or a bottom-up technique? And the clear answer to me is neither. And the phrase Ward always used was, we're working from known to unknown. And we're working one step at a time. So there's a way in which TDD is a reification, a way of setting down concretely a kind of style that programmers like Ward were able to do just naturally, where they wouldn't go launch into the unknown and write a whole bunch of code and then find out what it did, nor would they work strictly top down or bottom up. They would say, well, what's something we know? Now, sometimes there's a building block, and you know that if you have this building block, everything else is going to be easier. So you build enough of that building block in order to start using it at the next higher level. Sometimes you know what the system's overall behavior is going to be. Eventually, it's going to be this huge system. But for right now, we just log in and log out and we're done. Well, then we do something that looks kind of like top down. And then we do one logged in example and one non-logged in example. But now the logged in example then fragments into smaller and smaller things. And so we dive down and we demonstrate behavior at a lower level, believing, trusting through induction that it's going to compose into this higher level. Or sometimes we discover two orthogonal dimensions and we say, well, let me go work on all the different ways of calculating interest, and then I'm going to go work on all the different ways of calculating the time over which the interest is going to accrue, and then I'm going to put the two of them together. So I'm working not from top down, but sometimes, not from bottom up, but sometimes, but I'm working from the things that I know towards the things that I don't know. And I'm always going to do that one step at a time. And that's what TDD is intended, like the original intention for it is as a way of leaving yourself. If you're climbing a rock, you put pitons in so you can only fall so far. TDD, the masters of the craft just free climb until eventually, what happens. But if you're not an absolute master of the craft, you put the pitons in. So when you fall, because you know it's going to happen, you only fall so far. TDD is that. It's this exploratory, intuition-based discovery process, plus the safety of knowing, hey, I've gotten this far. I can't go backwards. I can't unget. So that's one of the debates I see, this top down versus bottom up, neither, known to unknown. And TDD is intended to help you at all scales, which is why I don't talk about unit tests and I don't talk about functional tests. The distinction doesn't really matter to me. Oftentimes I'll have one systemy test or two systemy tests, and then that quickly breaks into unit tests. I mean, if you map out the whole call tree, here's this request that comes in and there's this big old call tree. We can test any place in that call tree that we want. That's going to give us confidence that this system works as expected. So I have a warning for you writers. Don't fall in love with a word. When I was about 10 years old, I learned this word Desiderata, and I never had a chance to use it until this content. And I absolutely fell in love with and I thought, finally, after 50 years, I get to use the word Desiderata. Nobody knows this word. It has gotten in the way of people understanding this material. Here are 12 properties of good tests. And sometimes these properties interfere with each other. So tests should be isolated, composable, deterministic. Tests should be specific. That is, if something goes wrong, you know what went wrong. They should be behavior specific. That is, if the behavior of the code changes, the test results change. They should be insensitive to structure changes. They should be fast, readable, easy to write. They should be fully automated. And then at the macro level, they should predict the behavior of the system, and they should be inspiring. They should have you press the button, it comes green, you feel good. Okay, so those are 12 properties of tests, and I could give an hour to. I can give an hour talk on this slide. I give a 3-hour workshop on how your test suite stacks up against all these and how else you might be able to do it. But the point of this, and you can go to testdesiderata.com if you want to see more about this. There's a series of videos on it, yada, yada, yada. What I want to point out is there is a school of mocking which uses lots of mocks, uses mocks frequently in tests. And what I note is that mocks oftentimes introduce structure sensitivity. I remember going to a company that does video conferencing software, and they had a bunch of C++ code, and I was looking at that, and they were proud to show me their tests. Oh, we have all these tests, and they're so beautiful. And here's a test, and it says, first, verify that this function gets called with these parameters, and then verify that this function gets called with these parameters, and then verify that this function gets called 10 times with these 10 parameters. And I'm looking at the test, I'm thinking, I know exactly what the C++ code looks like. This test is the worst conceivable programming language syntax in the world. And indeed, you couldn't change a character in the source code without breaking all the tests. And that's not a useful test. That is not a double check. Mocks originally were a project management technique. We have this system, and then we pass the results to this system, and we want to write this system first. So we're going to mock out this system. Fine. For the moment, we mock it out, and then we just say, okay, and it's a 17, and we pass it to the new system. But we can pretend that it's there. This thing where, like, use mocks if mocks are a good idea, but think about what the design would need to be for you not to need mocks for some of the tests, even if those tests would be smaller, finer grained. So I'm sure that's going to set off a bunch of questions, and I hope that it does. Here's what TDD, so people come to me and they say, oh, this TDD stuff, I don't care, I don't use it, you can't make me, fine, whatever. TDD is intended to produce this list of effects on software development. Now, the first check is if it's not producing those effects, stop doing it or do something different. Think about why it's not producing those effects. I posted the other day on LinkedIn, do the tests that you write reduce the defect density of your code? And I got several kind of snarky answers like, no, the tests don't reduce the defect density. I'm like, well, stop writing them. My goodness. Or think about why they don't, because they sure catch errors for thinking errors for me. So I'm not going to read through the whole thing, but this is what it's intended. These are the effects TDD is intended to create. And if you don't use TDD and you want these effects, you need to create these effects some other way, or you need to just learn to live with worse communication, more defects, harder to make design changes, and so on and so forth. And that's fine. You can still write good code. You can still write profitable code. You can still get paid. You can still get promoted, even if you have anxiety, even if your flow isn't smooth, even if you feel overwhelmed sometimes. It's fine. But if you want a different experience of programming, you and your team, it is available. Beth Codes, my oldest, claims that TDD is a lovely diagnostic for programming skills. If you try and TDD something and you can't do it, there's some skill missing. Design slicing, behavior slicing, incremental design, something. So figure out what that skill, if only I had this skill, then I'd be able to TDD this, learn the skill and come back and see if it works. But, you know, if you don't want to use it, don't use it. One of the big surprises for me over the last probably 5 years is the violent anti-TDD reactions that I see. And it's really angry. You can't make me. Why are you telling me I have to do this? And I don't understand. Well, I mean, I'll tell you what I do understand of that kind of reaction, because it's a real reaction. People really do feel very strongly for some reason. And if we ourselves enjoy TDD, enjoy the benefits of TDD, would like to see more people using it. Well, the first question is, why would you like to see more people using it? I mean, for a while, I had a messiah complex, and that's not a good reason, but whatever, you do you. But if that's all true, understanding why there is this reaction, I think, is important. So one set of reactions I've heard from people embedded on teams. There's this one guy and he hates TDD just with a passion. And if he sees me doing it, he calls me names, and his code doesn't work. He'll go write for 2 weeks, try and merge stuff in, break the build, blame everybody else, and the code just doesn't work. So I think there is an element to this in resistance to TDD where the social maneuver here is taking responsibility for the behavior of your code. My code works, you can count on it, and I use TDD to demonstrate that. You can use other techniques to demonstrate that, and that's fine. But if you want to hide and have your code not work and not really admit it to yourself or other people, then TDD comes as a threat, a genuine threat. And then you got to deal with the actual situation that's there. Another big barrier to TDD is design skills and being able to slice your design decisions so you don't have to make them all at once. I call this the succession problem, and the books that I'm writing right now are all about this. You need to be able to reveal a design one decision at a time with running code in order to TDD effectively. Similar, you need to be able to reveal the behavior of the system a little at a time instead of all at once in order to TDD effectively. I mentioned this earlier, this sense of social status. Some people just don't want to write tests because testers just aren't as cool as us programmers. And that's, it's not my thing, but I think that's there. The big one that comes from inside the room is shaming. This, if you don't use TDD, you're not a professional programmer. I promised myself I wouldn't cuss on this talk, and I'm not going to cuss, but that is simply not true. And it benefits no one to say it, except maybe the self-righteousness of the person who's saying it. Shaming other people for the way they develop is never going to get anybody any better at anything. So please don't do that. We can have compassion for people. We can have appreciation for people. Wow, you didn't have time to work to learn how to work in this style and get the work you did done. But you got some work done. Congratulations. So what's next? Finally, work on design skills. The QR code is for a discounted subscription to the paying part of my newsletter, Tidy First. That's Substack.com. I published a book through O'Reilly Press last year called Tidy First, which is about empirical software design. Trying TDD and with different domains, front end, back end. James Grenning's done some really good stuff. I see the people appear, and I'm going to just keep talking until I'm finished. And lastly, but not least, try TCR. It's the next workflow for me past TDD. It's a lot of fun. I've seen a lot of resistance to it. I don't, it's fun. Try it. There's videos out there that'll show you how to do it. So there you go. TDD in context for the first half of its life. Now we're over to questions.
Wow, this was an energetic and insightful talk. Thanks a lot. I think we couldn't find a better person than you to have this summary of the themes of TDD. So yeah, we have a lot of engagement. The people are still commenting. So, but we have a few questions. We found pretty good ones. So let's see what they asked. First of all, we have from Ryan. I'm going to show 2 parts of it. So everyone says TDD is about design more than test, but why it has to be test driven? If we are more interested in getting design feedback with nowadays technology, would there be better approach? For example, AI. Having AI giving you real-time design feedback without having to twist my mind designing the test and spending the time to carefully craft the test so they do not limit future code refactor. So what is your take on this?
Great question. Great question. That depends on whether you think twisting your mind is a good thing or a bad thing. If you want to reduce the amount of twisting of your mind, you're going to learn less. And I want to learn more. I think the jury is out on how AI can contribute. It can certainly contribute. I'm trying lots of little experiments on how it can contribute. So try all the experiments. And then back to that first statement, it's more about design. It's both. Design, testing, programming, collaboration. It's cheaper than Xanax. It's all of those things. So yeah, I mean, even the premise of the question, I kind of quibble with. Could AI critique your design? Yeah, I think that would be an interesting experiment. Try it and let us know how that goes.
That's amazing answer, because that's what also a very similar thing was said by Dave Fairley in the beginning, and he said that we should optimize for learning. So if we don't use AI, then we learn more about the domain and all the things. So yeah, excellent. There is a good question, and it has been debated for a long time. So from Paul, Ken, do you think the term unit has caused more harm than good in our industry? So many people have told me I am doing it wrong because I don't mock out all collaborators as a result of that term. Nice.
The word unit doesn't help me, so I don't use it. If you look at the test Desiderata, there's 12 dimensions of tests. If you think of that as a 12-dimensional space where each one of them is a slider, there's lots of points in that space. Unit is just one tiny little point in that space, and functional test is a tiny little point in that space. We haven't explored that space at all. So what I'd like us to do is, I mean, then the Desiderata is my attempt to have a vocabulary for discussing this. Okay, I want tests that are easier to read, even though they're harder to write. Okay, and what is that? What does that change about the other properties of the test? Or I want tests that are faster, but they're less predictive. Or I want tests that are more predictive, and I don't care if they're slower. Like, there's lots of points in that space, and let's try. Everybody try different points in that space and give them useful names. And unit's just not one of those names. If your tests work for you, then you're not doing it wrong. You might, can you do it better? Maybe, maybe not, but yeah, doing it wrong.
Awesome. Well, the next one, probably $1 million question from Steven. I have had a lot of issues with other developers, mostly young ones. How do we effectively get them to unit test?
You have to experience it. You have to go through. I mean, I remember one of the real coaching moments that I had is sat down with somebody. We coded for 2 hours. We realized the design was wrong. We fixed it. Oh, what did we break? Push the button. It's all green. Oh, we didn't break anything. And we know we didn't break anything. How different is this experience than the experience we usually have with programming, where we're just like, YOLO. So I think as a senior, first, Stephen, we have the responsibility of being patient, because we were that younger programmer too, not so long ago. Okay, maybe quite a long time ago. First, we have a responsibility to be patient. And then secondly, we have a responsibility to create the environment in which the youngsters can learn these lessons themselves. And of course, they're not going to know them yet. This is a craft. Distributed systems design and mastering distributed systems design in 7 days. Burn it. Mastering distributed systems design in 35 years. That's the book I want to read, because it's just going to take that long. But if it takes that long, that means that there's something you got to learn year 1. This is very far distant than what you learn year 35. So you have an obligation as the opposite of noob is olb. As an olb, you have an obligation of creating the environment in which the noobs can learn.
Mm-hmm. Excellent. Yeah, it's all about the environment. That's always sets up the pace. Yeah. All right. Let's go to the next one. Let's use the time wisely. So here, one from Henrik. Just a thought, can a part of the issue be that a lot of companies have a QA department that is responsible for best practices around testing?
Why is this coming back? QA and a department. I'm 1,000,000% in favor of QA. I am 1,000,000% opposed to a QA department. It's just a misalignment of authority and responsibility, and it creates horrific incentives for everybody involved. So if programmers are routinely making mistakes, then they need feedback that makes it so they don't make those mistakes anymore, whether that's skills acquisition, new kind of testing tool, training, culture changes, incentives changes, whatever. Expecting a QA department to make sure that the code works is just a disaster. And it was common in the 80s and the 90s. We got rid of it for 15 years. It's coming back. The waterfall is coming back, people. And it won't work for all the reasons it didn't work last time, which means our skills at working in a different style become even more valuable, but it's coming back.
Awesome.
It was more of a rant than an answer, but there you go.
Yeah. For the last minute, let's pick one more question. Let's use it because amazing answers coming from your side. So from Benoit, what arguments would you use to counter to the common remark that I often saw in development teams? TDD slows development down. It is too complicated for an average dev team. So briefly in the next minute, if you could have a good argument of this.
With my oldest, Beth, I've started talking about the forest and the desert. In the desert, when you don't have enough time and you don't have enough skills and you don't have time to learn the skills, it makes no sense to TDD. If you're that close to dying, fine. in the forest, when there's sufficient resources, part of what creates the sufficient resources is TDD, so that we know that we can continue making changes. We know that the code works. We know that we're learning and growing. So from the forest, this question makes absolutely no sense whatsoever. Just the premises are wrong. But from the desert, the question makes perfect sense. And my heart goes out to people who are living like that. They don't have to, but my heart still goes out to them.
Amazing. Thanks a lot. And there is the last one. It's not a question from Emmanuel, and I think I can address this message to you on behalf of everyone, or most of the people in this talk. He says, Kent, I wanted to thank you because thanks to XM programming, it has allowed me to grow as a person, as a professional, and that is partly thanks to you. So, Kent, thanks a lot on behalf of everyone that you made the industry a better place.
I am so glad that you're finding my work helpful. I'm going to keep doing it.
Thanks a lot. And thanks for this talk. It was really amazing. And we have to jump for the next one, which is hexagonal architecture from Alistair Cockburn. We are going to start in 4 minutes. So yeah, and here is the lineup. We still have after that a few, 3 speaks, yeah. And yeah, thanks to organizers, to our sponsors, and of course, follow us on different social media platforms. So again, thanks for everyone, and especially to Ken Beck, and see you in the next one. Bye-bye.
Bye.